Hello everyone and welcome to the episode 27 of the Mobile Networks Overview course. This episode is mainly focused on the introduction overview on 5G, the new right now for the time of recording this video. It is a new generation in the mobile networks, but not so new, because right now a lot of studies for 6G has been started and it's going promisingly. Okay, so let's see what is 5G and what is the main architecture and what are the services introduced in this generation of mobile networks. The study of 5G and R&D was started in 2015 to make it a reality in 2019, and this goal was achieved in 2019. So what happened in this path? We can divide 5G into three main slices, into main three services, which I will describe for you in more details in the next couple of slides. But one of the most interesting and amazing features of 5G is network slicing, which I have many slides on this in the next slides. But what is network slicing? You can suppose that the network is like a cake, and based on the service that is your requirement, you can have a piece of cake, or maybe some, for example, this piece of cake, this piece of cake, many other pieces of cake we can, or maybe the combination of these pieces we can use based on our requirements. But based on this amazing network slicing, there are three main slices in the 5G. First is eMBB, Enhanced Mobile Broadband. As the name tells to us, this mainly focus on the high broadband services in order of gigabit per second. And in this slice, the bandwidth is really critical and important. It has high level of importance for the service and for the subscriber. Second is mission critical services, or uRLLC. It means ultra reliable low latency communication. Okay, uRLLC, as the name tells to us, it's very important for the high reliable services with very low latency communications. For example, like this, self-driving cars or wearable device, and many other devices that the response time is crucial, very important, and the latency should be at the minimum level of that. In these services, as you can see, the bandwidth is not as important at the first one. The third slice is what? mMTC, massive machine type communication, like M2M, IoT, Internet of Things, and many other things like V2X, vehicle to everything, connected cars, and so on. In this slice, the huge coverage and the line battery and some other things is very important. So if we can see, I told you that the a study of 5G had been started in 2015, and it is commercial launch at 2019. But right now we are in 2023, we are here. Right now you can see 4G LTE. 4G is in the mature level of itself and in the high demand and very mature service and very popular, the most popular and used one. But right now 5G is right now rolling out, and maybe until 2025 just it achieved to 20% of the subscribers, because of many things, many infrastructures and the mobile phones, handsets and so on. Right now, and we can also see that 3G is going to a sunset, and it's fading out, right? Also 2G, they are fading out, and we will have 4G and 5G in some developed countries. They also will shut down the 2G and 3G, but in some developed countries, sorry, they are planning to shut down 2G and 3G in developed countries. But in developing, the legacy network is still used. Okay, and this is global coverage and adoption. You can see in 2025 it is expected to around 1.4 billions of subscribers, near to 35% of penetration and coverage. Here is the roadmap. Of 5G. You can see some standards from 2016 has been released, like LTE B, 5G NR, new radio phase 1, many things like LTE-M, NB, narrowband IoT, and these releases, like the last one, release 17. And also we can see that the first commercial trials of 5G was here in 2017 in the United States for pre-commercial trials. This is pre-commercial, but the first commercial we can see here with the World Cup in Russia and 2018 South Korea Winter Olympics. This is also a nice idea, because in these Olympics this is entertainment, many crowd people are there, so it's a very good place to launch a new service. And also in 2018 fixed wireless access launched by United States. But in 2020 Japan was the first country to fully commercial mobile broadband launch of which I told to you, eMBB, a slice of 5G. And also in commercial, the first country who launched the commercial 5G system trial for Summer Olympics. So what are the motivations of 5G, and which services are based on this motivation? We have two main motivations: delay or latency and bandwidth throughput. Some services meet these two requirements: minimum delay and maximum bandwidth throughput. You can see tactile internet, the new generation of internet, virtual reality, VR, which means that first let me tell you, AR, augmented reality. It means that you wear a glass, you see the reality, but some augmented objects that are not real are added into, or maybe real, added into this area. Okay, this is AR. VR is completely virtual, like metaverse. And autonomous driving, we can see some of these applications needs these two requirements at the same time. And some other services like video streaming, and that you are familiar with them from the previous generations. So if we want to classify these slices that described for you in a big picture in the previous slides, the first one is based on the 2020 standard. The first one is eMBB enhanced mobile broadband. You can see the data rate is about 10 to 20 gigabit per second at peak, and at least 100 megabit per second whenever needed. The traffic is much more bigger than before. As you can see, 10,000 more traffic. The mobility speed is 500 kilometer per hour, and the use scenario is macro cell and small cells. Network energy efficiency, network energy is saved by 100 times. The second one is mMTC, massive machine type communication. Connection density is very important. Coverage should be long range, but you can see that data rate is not important very much. It can be very low, like for some applications like narrowband IoT. A little tiny stream of data bits are okay for this. For example, when you suppose a sensor in a car or a sensor in the farm, just some kilobit per second is okay for transferring everything. Battery life is very important because we are dealing with some sensors, wearable device, and so on. The cost is this cost should be ultra low cost, because we have many sensors, many devices, and access mode is asynchronous. And finally, the last one, ultra low latency, ultra reliable and low latency communications. Here the latency is very important and crucial and very critical and important. It should be less than order of millisecond, 1 millisecond air latency, air interface latency. It means between the device and the core and the radio access in the air, the latency should be in the order of millisecond. According to IMT 2020, it should be less than 1 millisecond. And end-to-end latency should not be more than 5 milliseconds. The reliability and availability is very, very important. It should be around 100%, 99.9999%. The data rate is and something between 1 and 2, not as much as the 1 and not as low as the 2. It's around 50 kilobit per second to up to 10 megabit per second. And the mobility is high speed mobility. Okay, I think for an introduction to the services and to the slices, this introductory episode is enough. In the next episode, I will try to discuss about more details and maybe some network elements and network architecture. I hope this video was useful and informative for you. And if it was interesting, please don't forget to subscribe in my channel, and you can introduce it to all your colleagues and friends. Have a good time, and hope see you in the next episodes. Bye.